If a random variable capital X has the probability density function f of x is equal to x e power minus x, the range x greater than 0, 0 x less than or equal to 0. Find the following mgf of x and hence obtain e of x and variance of x. Second one, cumulative distribution function of x, that is Cdf. The third one, p of x less than or equal to 2. So from the given PDF, we have to find out these. Okay. So now the given function is x into e power minus x in the interval x greater than 0. So we want to find out moment generating function of x. So the first one, mgf of x. Okay. So the formula for mgf, moment generating function, is mx of t is equal to expectation of e power tx. But x is a continuous random variable because x greater than 0, so that the formula is integral minus infinity to plus infinity e power tx into f of x into dx. This is the formula. Okay, now given f of x is x into e power minus x. So e power tx into x into e power minus x into dx. The range of f of x is x greater than 0. Greater than 0 means 0 to infinity. So now I want to integrate this. Before that, I am going to simplify. The simplification part, integral 0 to infinity x into, combine these two, e power tx minus x into dx. But you see the integral having the limit minus infinity, so that I want to form e power minus x because e power minus infinity is 0. So that I am going to take minus outside and the right hand side I am going to take x outside. Okay, so you can write like this, because this e power tx minus x, take x this side, right hand side. So when you take x in the right hand side, t minus 1 of x. But I want e power negative term, so take minus outside, e power minus 1 minus t into x. So that is, I wrote like this. Okay, so next I want to integrate this function. To integrate this, I want to apply Bernoulli's method. So what is Bernoulli's method? Bernoulli's method for product of two variable. Suppose x square into e power x, e power 2x may be like this. To apply Bernoulli's method, take algebraic term first, integrate the remaining term, e power 2x by 2, first term positive, next negative, differential of x square is 2x, and integrate this, e power 2x by 2, 2 into 2, 4, next positive, differentiation of 2x is 2, integration of this is e power 2x by 2 into 4, 8, next differential 0, so we can stop. So this is Bernoulli's method. With the same method I am going to apply here. This is algebraic term, this is exponential term. By applying the Bernoulli's method, take the algebraic term first, integrate the remaining term, e power minus 1 minus tx by coefficient of x minus 1 minus t. So take algebraic term, integrate the remaining term, minus differential of x is 1, integration of this is e power minus 1 minus t of x by minus 1 minus t, already minus into minus plus, so 1 minus t the whole square. So next term, the differential of 1 is 0, so we can stop. This is Bernoulli's method. Now the limit is 0 to infinity. Okay, so now I am going to substitute the upper limit. Substituting the upper limit infinity, e power minus infinity is 0. Substituting infinity here, e power minus infinity is 0. So 0 minus 0, upper limit, minus the lower limit. Substituting 0 here, 0 into anything 0, minus, substituting 0 here, e power 0. E power 0 is 1, so by 1 minus t the whole square. So now substituting the limit over, so minus into minus plus, so the moment generating function m x of t is equal to 1 by 1 minus t the whole square. So this is the moment generating function of the given function. Next I am going to find mean and variance, that is E of x and variance of x. To find mean and variance from the moment generating function, the formula is to E of x is first derivative of moment generating function with respect to t. There you put t equal to 0. That is E of x. To find E of x through the MGF, differentiate with respect to t in mx of t and then put t equal to 0. For E of x square is same moment generating function, differentiate twice, 2 times mx of double dash of t, and there you put t equal to 0. Then by using this we can find variance. Okay, so that given mx of t, so here I am going to differentiate with respect to t. So mx dash of t. So I am going to differentiate this, but differential of 1 by x square is minus 2 by x cube. So this is the formula. So by using this, 1 by x square is minus 2 by x cube. So this is the differential formula for 1 by x square. 1 by x square is minus 2 by x cube into differential of inner term, t differential is minus 1. So differential part over. So this is 2 by 1 minus t the whole cube. So this is the first derivative. Next I am going to differentiate second derivative. Next I am going to find second derivative. So mx double dash of t. So I want to differentiate this, but the formula for 1 by x cube is minus 3 by x power 4. So here take 2 outside. 1 by x cube is minus 3 by x power 4 into differential of inner term is minus 1. Okay, so now further simplification, minus into minus plus, 3 into 2 6 by 1 minus t power 4. Okay, already I told you E of x is in the first derivative put t equal to 0. Okay, so this is the first derivative, put t equal to 0, 2 by 1 minus 0 the whole cube. So that it is 2. E of x is 2. So next I want E of x square. E of x square is in the second derivative put t equal to 0. So this is the second derivative, put t equal to 0, 6 by 1 minus 0 the whole power 4. Therefore it is 6. So by using E of x and E of x square we can find variance. So next, to find variance of x, E of x square minus E of x the whole square. So variance of x is equal to E of x square is 6, already we found, minus E of x is 2. 2 the whole square is 4, 6 minus 4 is 2. Therefore E of x is equal to 2, that is mean is 2, and variance of x is also 2. So this is the answer of the problem. So next I am going to find cumulative distribution function. Cumulative distributive function is capital F of x. The formula is integral minus infinity to x f of x dx. So from the given function, f of x is x into e power minus x into dx, and the range starts from 0 because the range is x greater than 0. Greater than 0 means start from 0 to here x. Okay, so now to integrate this I am going to apply Bernoulli's method. So what is Bernoulli's method? Take algebraic term first, integrate the remaining term. E power minus x integral is minus e power of minus x. Formula minus differential of x is 1. Next once again integration of this is minus plus, so e power minus x. So next differential 0, so we can stop. After integration substitute the limit 0 to x. So substitute the upper limit first. Wherever x put again x, so minus x e power of minus x minus substitute x here, same function will come. When you replace x by x, same function will come. Minus substituting 0 for here, 0 into anything 0, minus substitute 0 here, e power 0. E power 0 is 1. So now minus into minus plus e power 0 1, so 1 minus x into e power minus x minus e power of minus x. So this is cumulative distribution function capital F of x. So this is capital F of x. Okay, next I am going to find p of x less than or equal to 2. To find this, we can use PDF or we can use CDF, because the formula p of x less than a is using PDF minus infinity to a f of x dx. But using CDF, this can be written as like this, and then f of a minus f of minus infinity. We can use anything, but in this problem, if you use PDF method, we won't integrate cap small f of x, but we have to apply integration, that is Bernoulli's method you have to apply. But if you use capital F of x, simply we can subtract. So that I am going to use second method using CDF. So now in this problem, to calculate p of x less than or equal to 2, I am going to use CDF, cumulative distribution function method. Okay, so that this function can be rewrite as x less than or equal to 2, but the range of x is given, x is greater than or equal to 0. Greater than or equal to 0 means start from 0, end with the infinity. In this range, 2 may be here. What is x less than or equal to 2? Less than or equal to 2 means it covers 0 to 2. So that 0 less than or equal to x less than or equal to 2. Okay, so now by using CDF method, this can be written as f of 2 minus f of 0. But already in our previous one, we found f of x. What is f of x? This is f of x. Here I want f of 2. So that put x equal to 2 here. For f of 2, put x equal to 2. 1 minus 2 e power minus 2 minus e power of minus 2. And then minus f of 0. Put x equal to 0 here. Put x equal to 0. So 1 minus 0 minus e power 0. Okay, so the further simplification, 1 minus this into this same term, 3 into e power minus 2 minus 1 minus 1. 1 minus 1 cancel. So finally the answer for p of x less than or equal to 2 is 1 minus 3 into e power minus 2. So this is the answer of this term.